I also do, just so you know, I do some short editing as I do things. So this, what we're gonna cover is the trig you need to know. So we're going to use a right angled triangle. So we've got a right angled triangle. And here's our right angle. First of all the angles in my triangle, the sum of the angles in a right triangle are going to equal 180 degrees. Actually, the sum of the angles in any triangle equal 180 degrees. And that's one of those factors about triangles. But if we know this one is a right triangle, a right angle, and this is how you designate an angle, a right angle is equal to 90 degrees. So we've got that right angle equal to 90 degrees. We know the sum of the angles in a right triangle are 180 degrees. The sum of the angles in any triangle is equal to 180 degrees, but that's the way we start. In conventional, the way I have written this triangle, and the way you're going to see it in your book, you're going to see this as R. And you're going to see this as X. And you're going to see this as Y. That's traditionally how the book is going to do it. Now I'm going to help you out, because one of the things that we're going to do is we may be working with a right triangle that looks like that. And that X and Y might get a little confusing, and we're going to talk about it a little differently. One of the other things that you know about this is we know the good old Pythagorean theorem that says a squared plus b squared is equal to c squared. And in this case, if we write it with respect to our triangle, it's going to look like this. So that's just the Pythagorean theorem. And now we've got it in terms of the way that I drew my triangle. Now, what's cool about triangles is that we can deal with ratios. And we can use those ratios, and we talk about them being sines and cosines. So I'm going to rewrite my triangle just a little bit so that you have both of them. There's my right angle. I'm going to call this angle theta. You do have all of this information in the appendix of your book, and it is in one of the first two chapters. I can't just right off the top of my head point you to where it is in the book, but you do have it. We're going to call this the hypotenuse, right? So just like what I have on for my R, we're going to call that the hypotenuse. We're going to see why we call that R in a little bit. Then we're going to call this the adjacent side, or the side that's touching my angle that I'm interested in. And this is the opposite side of my triangle. So now I can write this as my opposite squared plus my adjacent squared is going to equal my hypotenuse squared. So you now have another way to look at your sheet. So that's all well and good. And now we're going to use some ratios. And if I'm looking at this angle, the cosine of that angle is going to equal the ratio of my adjacent over the hypotenuse. Or if I use my traditional diagram for my triangle, this is going to equal X over R. So I can determine this angle in degrees. So if I have a complete circle, remember my complete circle If I do this mathematically, the complete circle is equal to 360 degrees. All the way around it's 360 degrees. So I can look at this angle and be able to get that value. So if I know the adjacent side and the hypotenuse, I can calculate that angle. The ratio for the sine of the angle is equal to the opposite over the hypotenuse, and that's equal to y over r. And then I can do one other, and that's the tangent of the angle, and that's the opposite over the hypotenuse, and that's going to equal y over x. And a couple of other fun things is if I did that, right? If I do this, if I do sine of the angle divided by the cosine of the angle, that's going to equal the tangent of the angle, because this is going to be the opposite over the hypotenuse divided by the adjacent. Oops, sorry, that's adjacent. I wrote down hypotenuse. Adjacent over the hypotenuse. These cancel and I get opposite over adjacent. So I can get it this way, I can use it this way, I can use it that way. Couple other things that we're going to need to know. The cosine squared plus the sine squared is going to equal to 1. We're going to use that down the road a little bit. So that's one thing. And my angle is going to equal what we call the arc sine. And this one is going to be my opposite over the hypotenuse. And that is the key that you're going to use on your calculator. And the angle can also equal the what we call the arc cosine. And then I can also do that for my tangent. Okay. Now, the whole reason we do this is because this is going to allow us to do interpretations of our physical systems. So one thing that we deal with is this. So I have my Cartesian coordinate system. I have X and I have Y. If I plot a point here, that point is defined as X, Y. Well, I can also locate that point in space. This is a Cartesian system. I can also locate that same point in space, my X, Y point in space, by an R theta, and we call this polar coordinates. So I can convert back between Cartesian coordinates and polar coordinates. So I can locate that same point a couple of different ways. So if I have a point, we're going to do this as a quick problem here. This is point 1, 2. My X and my Y. My R is going to equal the hypotenuse. My angle is going to be the arc tangent of my adjacent. Oops, I wrote that in the wrong order. Sorry, this is 2, 1. Because there's my 1, 2, 1. So that's going to be my adjacent is 2. my y is 1, and now I can write the angle, and I'm gonna actually show it to you on the calculator. You wanna make sure you're in degrees on your calculator. And I'm gonna do the arc tangent of 2 divided by 1. And it's gonna give me an angle of 63.4 degrees. R is equal to the square root of x squared plus y squared. That's the square root of 2 squared plus 1 squared. Square root of 4 plus 1. Square root of 5. I take the square root of 5, I get 2.24. Now, because I didn't give you any units here, we don't necessarily have units because I'm just doing a mathematical representation. Right? So let's do this. Have a building. So we're going to do this in a physical sense. I have a building. And I've got a ladder leaning up on my building. I don't know the length of my ladder, but I do know that I've stepped off 1 meter away from the wall. And I do know, because I do this all the time, I know that that height is 2.5 meters. So this is my ladder. What is the length of the ladder? I'm given my picture. I know what I've got. Well, this is going to be easy. The length of my ladder is going to equal my x squared plus y squared, square root of that. And that's going to be the square root of 1 plus 2.5 squared. Now I'm in meters, so underneath my square root, I have meters squared. So I'm going to end up with meters at the end. So this is an actual real value. So I get 1 plus 2.5 squared. Take the square root of that. And my length of my ladder is going to be 2.69 meters. Okay. All right, let's do another one. I've got a tree. This is a really funky tree this morning. That will make it look a little bit more like a tree. Okay, I got a tree. And we know that the sun, and I'm going to draw that typical little kid sun, right? There's my sun. There it's coming through. It's shining down on my tree. And we are standing, and I'm going to give myself a reference point. And we're standing 5.6 meters away from the tree. And we're going to use a lovely little handy dandy app on our phones, which we can. And this goes up to the top of my tree. And I'm going to measure that angle. So because I can do that, this is a lot easier than measuring my tree. And we're going to measure the shadow. And there is a video where I've actually done this using the parking stand items out on the circle here at Tonkawa. And we're going to measure this angle at 62.5 degrees. We want to know the height of the tree. Okay, I want to know the height of the tree. Maybe I misspelled that today. But that's what we've got. So I've got an angle and I have my distance. Remember, this would be the hypotenuse, this is going to be the adjacent, this is going to be the opposite. So I want to solve for opposite. Okay. I have my three ratios. So what I know is I know the angle and I know the adjacent. That's going to mean I'm going to use the tangent function because I know this one. This is what I want to know, and I know that one. So I'm going to start with my tangent. And I'm going to do my opposite over adjacent. I'm going to go ahead and do my algebra first. I'm going to take my adjacent times my tangent is equal to the opposite. Now I'm going to plug in my numbers. I'm going to do my 5.6 meters. The tangent of the angle is 62, for the angle 62.5 degrees. That's going to equal my opposite, which is what I'm trying to solve for. And what I do is I do my tangent first in my calculator. So I have that, and then I multiply that by my 5.6 meters, and I'm going to end up with 10.76 meters for the height of my tree. If I wanted to keep the appropriate significant figures, just to keep us reminded on the appropriate significant figures, I end up with that. And so we can determine the height of our tree using trigonometry. We can also do some really cool things. We can use this to determine height of distance objects. So let's say we're on a city block here, and I have a building. So here's my building. And we want to know the height of my building. Nope, I had it spelled right today. Okay. And we're going to do it this way. I'm going to start here and I'm going to take an angle measurement. And I'm going to get this first angle, and that first angle is going to be 45 degrees. I'm going to walk 1.5 meters. And I'm going to take a second angle. And I'm making up these numbers, so this side may not be a realistic number. Okay. I'm doing this with a maybe non-realistic number because I'm just making up numbers. And this angle now is 47 degrees. I want to know the height of the building. Well, we already figured out that the tangent of the angle is going to equal the opposite over the adjacent. In order to do this, I'm going to have to use two equations, two unknowns. And we will do a lot of two equation, two unknown problems throughout the semester. But we're going to show this one using trigonometry. So the first triangle is the tangent of the angle, which is going to give me the opposite side, and it doesn't matter, it's going to be the opposite side on both of those. And the first one is going to be, we're going to call this X. So the first one is going to be that. And this is my first angle. The second triangle is tangent of the second angle, which is the opposite of x minus 1.5 meters. I know my angle. I know this angle. I don't know x, but opposite is what I'm trying to find. So my two unknowns are x and my opposite. Well, I'm going to solve for x. I'm going to solve for x here. And I'm going to have x is equal to the opposite divided by the tangent of my angle. Now I'm going to plug it into this equation. I'm going to plug it into this equation. So the tangent of my second angle is equal to the opposite divided by the opposite divided by the tangent of the angle minus 1.5. So I have all those there. So now I'm going to clean this up and I'm going to solve for opposite. So I get tangent of the angle 2 times the opposite divided by tangent angle 1 minus 1.5 equals opposite. I'm going to get tangent of angle 2 over tangent of angle 1 times the opposite minus 1.5 tangent angle 2 equals opposite. I'm going to rewrite that equation so that you all can follow the steps. So I get my tangent angle 2 divided by the tangent of angle 1 opposite minus 1.5 tangent angle 2 is equal to opposite. I'm going to combine my opposites over here. So now I'm going to get tangent angle 2 divided by tangent angle 1 opposite minus opposite is equal to 1.5 tangent angle 2. Factor out my opposite. And I get tangent angle 2 tangent angle 1 minus 1 is equal to 1.5 tangent of 2. So the opposite is going to equal 1.5 tangent of angle 2 divided by this factor. Now, I wrote it out in all the gory details. You could have already plugged in the numbers and it may have made it a lot prettier to look at, a lot prettier to solve, but we're going to take care of this. So this is going to be 1.5 tangent of my 47 degrees divided by tangent of 47 degrees tangent of 45 degrees minus 1. This is meters, so I'm going to be in meters. So we've got that there. So now I'm going to turn on my calculator and do it. So 1.5 times the tangent of 47 gives me 1.608. I'm going to carry some extra significant figures. Tangent of 47 divided by the tangent of 45 gives me 1.072 minus 1. So I'm going to get 1.608 divided by 0.072. Again, I'm in meters. And if I punch things into the calculator right, I get that the height of the building is 22.2 meters. Yeah, I'm not sure, somebody asked the spelling, I'd have to go look it up. Height's one of those words, is an I before E, except in words like neighbor and way. So it's where we're at. I probably have it misspelled. But now we've got that calculated, and if I want to determine X, I now can solve for X. X is equal to my 22.2 meters divided by the tangent of 45 degrees. And so we can figure out how far away we are from the building. And we were actually at about 22.2 meters away from the building. So you can actually do that. Okay, that's two equations, two unknowns, using our trigonometry. And then we've got your trigonometry, kind of a handy dandy worksheet for your trigonometry, so that if you were writing out notes, you've got that. And I'm going to stop there and open it up for questions, because I really don't have time to start into a different topic. We will start with motion on Friday.